So before we get into figuring out the angle measures, I thought this was an interesting problem to work on because it involves more than just a random triangle thrown at you. It's something that we all kind of heard of and can apply to. So this is what is considered the Bermuda Triangle. It's not necessarily officially the Bermuda Triangle, but this is what most people are referring to when they refer to the Bermuda Triangle. It's Bermuda to San Juan to Miami. It's the space included in there. And it's claimed that that's 500,000 square miles in area. So what we're going to do is we're going to use these measurements to see how close that 500,000 square miles is. Now what we do know is this is an isosceles triangle. An isosceles triangle means that this side is equivalent to this side. It also means that these two base angles are equivalent. But what we need to do is we have to find area. An area of a triangle is 1/2 of the base of the triangle times the height. We don't know the height of this triangle. The height of this triangle is that. Because this is an isosceles triangle, it creates two separate right triangles. So we have an angle measurement here. We know what this base is. The entire base is 954.8 miles. So what we could do is divide it in half to figure out what half of this base is for this one triangle. So I'm going to do my 954.8 and divide it in half. And that's going to tell me that this side here is 477.4 miles. So according to my diagram right now, I have an angle measure. I have the adjacent side. But what I actually need is the opposite side. That's going to be the height of my triangle that I can apply into the area formula. So in order to find that height, I'm going to apply my right triangle trig. And we've said that this is the adjacent side. And what we're looking for is the opposite side. So the ratio that uses opposite and adjacent is tangent. So if I do the tangent of that base angle, which is 62.5, it's going to be the opposite, which is the height of our triangle divided by 477.4. And I remember I got that because I divided the full distance between Bermuda and San Juan in half. Okay, so to solve this, I'm going to multiply both sides by 477.4. So 477.4 times the tangent of 62.5 is going to equal the height of my triangle. So I'm going to take that last answer and I'm going to multiply it. One second. I'm going to do 477.4 and I'm going to multiply it by the tangent of 62.5. And again, I'm just using the same calculator I was using before, so I know I'm already set to degrees. So that means that the height of this triangle here, which is the missing piece to find the area, is 917.08 miles. Okay, so now I can go ahead and figure out what the actual area of this triangle is and see how close it is to the 500,000. So it's going to be 1/2 of the base of the whole triangle, which was the 954.8 miles, times the height of the triangle, which is what we just calculated. So that's 917.08. So I'm going to go ahead and find that area. I'm going to do 0.5 as my 1/2 times 954.8 times 917.08. And I get that the area is actually 437,830. Well, let's round it to 14 square miles. That's pretty close to the estimation of 500,000. It's a little 500,000 is a little bit of an exaggeration, but it's not that far off. So I found that to be a really interesting problem because it didn't necessarily right away speak to me as being right triangle trig until I started breaking that triangle apart. Okay, so now how do we solve for when the angle measure is actually missing? So on a lot of calculators, you'll see an inverse key. Okay, and some calculators, in order to do the inverse, you have to hit a second button. On Desmos, it's just the ones that have the -1 right next to the originals. Okay, so that's what we're going to use. So we know whenever we normally have an operation on the one side of the equation, to do it to the other, we do the inverse operation. So that's actually what I'm going to do here. I'm going to move this. Oh my goodness, that didn't move the way I planned. Let's try this again. I'm going to, nope, that didn't move the way I planned. Let's just go with the way it looks. Okay, so to get this equation, so that I can find out what the angle measure is, I'm going to do the inverse sign on the other side. So I'm going to write it as theta, which is just like x, but we use it to represent a missing angle measure, is equal to the inverse sign. When I take that sign to the other side of the equation, I do the inverse of it. We already understand that -1 exponent, okay? And that would be of 4/5. So when I put that in my calculator, I would go here and I would do this inverse sine function, and I would put in the 4/5. Get my parentheses in the right place here, and that tells me that my angle measure is actually 53.1 degrees. That's my missing angle measure. For the next one, I have the cosine of the angle is equal to this. Well, to get rid of the cosine, what I'm going to do is I'm going to put the inverse cosine on the other side of the equation. And that's going to give me my angle measure. So I do the inverse cosine. Notice the -1 up there. 0.732. And that gets me an angle measure of 42.9 degrees. It is important that you write the degree symbol on there, because leaving the degree symbol off actually means something else. Okay, so the next thing I'm going to do is I see that the tangent of the angle is equal to this ratio. So to get rid of the tangent, I'm going to take it to the other side of the equation, and I'm going to say the inverse tangent of 0.285. And I can put that in my calculator and do the inverse tangent of 0.285, and I find out that that is actually the angle measure of 15.9 degrees. And just like our last unit, we're going to have to pay really close attention if there is a requirement of rounding. This one didn't have one, so I kind of have a mixed bag, but I rounded everything to the tenths place. I don't like to put it as a whole number unless it is actually a whole number. I want to show that it's an estimation. I should be putting approximately equal to signs here to be correct. All right, so let's see if we can apply this to these problems here when we're trying to find the angle measure. Here I don't know the angle measure, but I do know what the sine is. So if I'm looking at angle A over here, sine is the opposite over the hypotenuse, so that's 12/20. Cosine is the adjacent over the hypotenuse, which is 16/20. And tangent is the opposite over the adjacent, which is 12/16. Now that didn't give me the angle measure, but what I could do is for each of these, I can go, so to find out angle A, what is the inverse sine of 12/20? To find angle A, what is the inverse cosine of 16/20? And to find angle A, I could also do, what is the inverse tangent of 12/16? And all of those should get me what angle A equals. They should all be the same. So let's try the inverse sine of 12/20 and the inverse cosine of 16/20. We're talking about the same angle. It should be getting us the same angle. And the inverse tangent of 12/16. See, it gave us the same angle every time. So that tells me that angle A is 36.9 degrees. Now, There's multiple ways then to go back and figure out angle B. If I know this is 36.9, an easier way than going through all this to figure out angle B would just to say, oh, all three of those angles have to add up to 180 degrees. But we want to play with the ratios a little bit more. So if the sine of B, so up here is B, so let's do it with the ratios and show that they all equal 180. Sine is opposite over hypotenuse, so that's 16 over 20. So to find the angle measure, we're going to do the inverse sine of 16 over 20. The cosine of B is equal to the adjacent over the hypotenuse, which is 12 over 20. So to figure out the angle of B, I'm going to do the inverse cosine of 12 over 20. And the tangent of B is the opposite over the adjacent, which is 16 over 12. So to find the angle B, I'm going to do the inverse tangent of 16 over 12. And all three of those should get me the same angle measure for B. So inverse sine of 16 over 20, inverse cosine of 12 over 20, and inverse tangent of 16 over 12. And you'll see they all got me 53.1 degrees, 53.1 degrees. And I bet you now, if I take all three of these angles and add them together, I should get 180. So 36.9 plus 53.9 plus the 90-degree angle that was there. And you see I end up with a little bit extra. And that had to do with, well, for one, that had to do with the fact that I didn't put this number in there right. It was a 1. It did end up with 180 degrees, but if you're slightly off, it's because we did some rounding in here, and it would have been okay. So they do all add up to 180 degrees, so we know we've done that correctly. Okay, so we'll do some application problems in the next video.